Hello, I'm back. Okay, so let's finish this 2.5 rational functions. And in this video, I will go over how to graph a rational function. And I don't know if I have my graphing calculator with me. I'll try to do it without one. So that you can do one without when you try this classwork. So in this video, I will go over page 6 and 7. And I will ask you to try page 9, the classwork on page 9, graphing rational functions classwork problem. This will look a lot like the one page that you will have to do on exam 2. And we will talk about how we're going to do exam 2 maybe like next week. We should think about that. Yeah. But the goal for this video is for you to be able to complete the classwork on page 9. So let me go over page 6 and 7 with you. I think this is going to be a little bit shorter, but it may have some new information, so please watch, okay? All right, page 2, and I made this, page 6, example 2, I made this because I know on the Alex homework, you will have a topic that looks like it, just reading the graph of a rational function. We have a graph given, so let's find all the things they want us to find. Assume that all asymptotes and intercepts are shown and that the graph has no holes. Okay? Use the graph to complete the following. Find all x and y intercepts. Let me find the x-intercept first. X-intercept is when where the graph touches the x-axis. So x-axis is what I am highlighting with my yellow Sharpie. Did the graph touch this yellow or the x-axis anywhere? Take a look. The graph is here. This piece is not touching the x-axis at all, right? This one is just above it. And look at the middle one though. It's gonna go up, and oh, it touched it right here. It crossed it, and it's going up that way. So we found x-intercept right here, and this is that's -2. So the x-intercept is at. Let's write it down. X-intercept. Whoopsies. X-intercept. I can't spell. Is at x equals -1. I can't remember if they wanted you to do an order pair or a just an x value. So if you want to give them a order pair, it's -1, 0. All right, let's find the y-intercept. Oh, before I go on, is there any other x-intercept? This piece right here, it's not going to touch the x-axis. It's going to just get really, really close as the x value keeps on going to the increases, but it's not going to touch that x-axis. Now let's find the y-intercept. Y-intercept is where this graph touches the y-axis. The y-axis is right here. And as I was graphing this yellow highlighted line, I saw that my graph touched the y-axis at this point right here at +1, at y equals 1. Therefore, the y-intercept is at 0, 1. Okay? So just like that, Alex will give you different pictures. I want you to just find the x and y intercepts, just like you've been doing for any other graphs. All right, but the new part, the vertical and horizontal asymptotes. Now, in the second video, we kind of already found them. You can see the vertical asymptote is this dotted vertical line. We have one right there, and we have another one right there. So we have two vertical asymptotes. Let's write the equation for these two pink dotted lines. So the vertical asymptotes are at x equals -4. And remember, don't just give me -4. Don't give me just a number or y equals. For the vertical asymptote, you should say x equals the number, okay? And what's the other one? X equals, take a look, this one right here is at +2. So we have two vertical asymptotes, x equals -4 and x equals +2. Now let's find the horizontal asymptote. The dotted horizontal line is actually the x-axis right there. So what's the equation of the x-axis? The horizontal asymptote is at y equals 0. Okay, so we are done with part A and B. let's talk about the domain and range of f. Domain and range of f. Let's do the domain first. The vertical asymptotes, remember those are the zeros of the denominator. And when we found the rational functions domain, we found the excluded values by first setting the denominator equal to 0. So what we got going on is that the graph or the function cannot go past these two vertical lines. So take a look. We're going to have to write the domain in 3 pieces. The one to the left of this pink dotted line, the one in the middle, and then one to the right of it. So we're going to have 3 intervals. Just because I want to write the domain and range on using this picture, I'll write them answers here, but I will copy them down on that paper soon, okay? So here's the domain. And in order for you to find the domain of a rational function, use your asymptotes. Now, there is the vertical asymptote at -4 and another vertical asymptote at x equals +2, okay? So everything to the left of -4, how do we write that? That's going to be from -infinity to -4. Close the parenthesis and draw the union symbol. So that's everything to the left of -4. Now let's find everything in between -4 and 2. From -4 to +2. But notice that we're not drawing square brackets, just regular parentheses, as you know, we can't really touch those two values. And the very last one is going to be everything to the right of that vertical asymptote. So from 2 to, keeps on going forever to the right, +infinity. So that is the domain here, okay? Now, you are, okay, let me try to be careful. Because vertical asymptotes are the zeros of the denominator, we're never allowed to cross the vertical asymptotes. Okay, we're never allowed to cross the vertical asymptotes. So you can almost always use the vertical asymptotes to write the domain of a rational function, but that's not going to be true for the range and the horizontal asymptote. Because let's take a look. Remember, the horizontal asymptote was y equals 0. Does it touch it? It crossed it. So that same rule doesn't really apply for horizontal asymptote, because the definition of horizontal asymptote is what the graph is doing to the extreme right end and to the left end. So really, the definition of horizontal asymptote doesn't really talk about anything that the graph can do in the middle of the graph. So as the graph is going to the right side, we agree it's approaching y equals 0. And as it's going to the left side, we agree it's approaching 0. But in the middle, it crossed it. So let's write the horizontal asymptote by looking at this graph. Notice how this graph will go down forever, right? So to this end, it's going to go down, it's going to go down. So the range is going to be from -infinity to, and horizontal asymptote, you have to be kind of careful, because some graphs, it skips it. It doesn't get to cross the horizontal asymptote. But this graph, it does cross it right here. It did cross it right here. It does cross it at this point. So we're not going to skip the horizontal asymptote. And in fact, it just keeps on going up forever. So the range of this graph is -infinity to +infinity. And I will show you another case on page 7 where we have to skip the horizontal asymptote. So the range will be a union of 2 separate intervals. But this graph, the range is actually all real, because it goes down forever to the bottom, and it keeps on going up, and it will eventually cover all the y values on the graph. Okay, so I wrote the answer for C up here so that I can use the picture. So I didn't really write that down there, but that's okay. So I am done with page 6. Let's do the very last one. Okay. I do love putting something like page 7 on your exam, and I do have one that I'm going to ask you to try after this. So example 3, we're just doing everything here, everything together, and eventually we will graph one without a graphing calculator. I'll try. Let's find the vertical asymptote and graph it. Remember, vertical asymptote is when the denominator equals 0. So x minus 2 equals 0. vertical asymptote is at x equals positive 2. So graph that with the dotted line, okay? Dotted x equals 2, a dotted line. Okay, let's do the horizontal asymptote. Now, horizontal asymptote, you have to look at the cases. The degree of the numerator is 1. Degree of the denominator is also 1. Since n equals m, take the ratio of the leading coefficient. Leading coefficients, let me circle them, okay? The leading coefficient of the numerator is negative 3. Leading coefficient of the denominator is not written here, but it's just going to be 1 because it's 1x. So horizontal asymptote is at negative 3 over 1. So horizontal asymptote is y equals negative 3. Okay, so this we explained. I explained this in my second video. So hopefully you watched that one. So let's graph that. Y equals negative 3. So down at negative 3, graph a dotted horizontal line. Okay. So we got our horizontal asymptote and vertical asymptote plotted. Okay. Now, find the slant or oblique asymptote. Now, do we have one? In order for us to have a slant asymptote, remember the numerator degree has to be bigger than the degree of the denominator by exactly 1. When they are the same, we do not have a slant asymptote. So none. All right, let's find the X and Y intercept. Now, this class is graphing calculator active, and if you would like to use a graphing calculator, you may be able to just find them by graphing, but I will show you how to do them with that one, okay? So X intercept is, let me do that first. X intercept is when y equals 0. So I set the entire function equal to 0. 0 equals 4 minus 3x over x minus 2. F of x, I set that entire thing equal to 0 because that's what y is. This is how we find the x-intercept. Now, when is a fraction 0? Fraction is a 0 and the numerator is 0, but if we ignore that and just try to solve for it, what can I do to both sides? I can multiply both sides by x minus 2. Okay, I can multiply both sides by x minus 2, so that cancels. And x minus 2 times 0 is simply 0. So feel free to just set the numerator equal to 0 when you are solving an equation like this. So I have that. Let's solve this for x. I will have 3x equals positive 4. So x is equal to 4 over 3e. Now I'm going to plot that 4 over 3. On the x-axis, right? So 4/3, about like 1.3 repeating. It's not the nicest, but I'll try. 1.3 repeating-ish. So a little bit after 1, I have a point right here. I'll just make my dot really fat so that at least it touches at that exact point somewhere. Okay, that looks good. So that's my x-intercept. Let's find the y-intercept. Now, y-intercept is when x equals 0. Now, this one is going to be a little bit easy for us to solve. So plug in 0 into x, okay? That will be y equals 4 minus 3 times 0 divided by 0 minus 2. Let's simplify this. That will be 4 over negative 2. So y-intercept is at y equals negative 2, okay? Right here, right there. So that's it for part C. Let's keep going. Does the graph of f of x cross the horizontal asymptote? Should work. Does it cross? And then now this one, we're gonna have to check it. So what's the horizontal asymptote? Horizontal asymptote is y equals negative 3, right? We found that. Take a look. Y equals negative 3. So we're trying to see if our f of x crosses it. Now, let me write down f of x on the side here because it was way up there. F of x is equal to 4 minus 3x divided by x minus 2, right? Now, I'm trying to see if this function will cross y equals negative 3, or in order for it to cross it, it has to first touch it, right? So what I'm going to do is I'm going to set y equals negative 3. I'm going to set this function equal to negative 3. Negative 3 equals 4 minus 3x divided by x minus 2. All right, I'm solving this, so I will go ahead and multiply both sides by x minus 2. X minus 2. If I do that, the x minus 2 on the right side cancels out, right? But I'm going to have to distribute this. I'm going to have to distribute that negative 3, and I will get negative 3x plus 6 equals 4 minus 3x. Now, what can I do to both sides? Take a look. Did you notice there is negative 3x on this side and negative 3 of x on that side? So I'm going to go ahead and add 3x to both sides. Let's see what happens. If I do that, bring down the 6 equals, bring down the 4. Uh-oh, that can't be true. So you know what we got is we had an equation that had no solution. In other words, there is no x value that will make this function equal to negative 3. So this is kind of showing, this is a proof that no f of x does not cross the horizontal asymptote of y equals negative 3 because there's no x value that will satisfy this equation where we set the y value equal to negative 3. So that's what I want you to kind of show me something that's not true, and that's enough for you to say, oh, that's my little proof right there that f of x will not cross the horizontal asymptote. So using that, I can answer the range. Well, let me do the domain first. Domain, we're going to use the vertical asymptote. The vertical asymptote is at x equals 2, right? So the graph will go forever to the left of negative 2, but it's going to have to stop at, not negative 2, at positive 2. So the first interval will be from negative infinity to positive 2. Draw the union symbol. And then you jump that 2. And then you start back from 2, go all the way to positive infinity. So that's the domain of this rational function. And what was this? This was the vertical asymptote. This was the vertical asymptote. Asymptote. I didn't spell it right. Guys, I've been going for a long time now. I may need to take a break. Asymptote. Okay. So when you are finding the domain of a rational function, use the vertical asymptote. That's the little the line that you're gonna have to jump. Now range. Remember we just show on part E that the graph will not cross or even touch y equals negative 3. So use the horizontal asymptote. Y equals negative 3. This is the horizontal asymptote that my little graph will not be able to cross. So what's that going to be? Go from negative infinity to negative 3 union, but start back at something that is slightly bigger than negative 3 and go all the way to positive infinity. So that's it. Now the end behavior, and I put it here just to kind of reinforce the definition of horizontal asymptote. But end behavior of a rational function is really talking about the horizontal asymptote. Remember, the horizontal asymptote is y equals negative 3. That means as x is getting really, really big, or if the graph approaches positive infinity, or as it's going to the right side, f of x will approach negative 3, the horizontal asymptote, and to the left extreme, as x approaches negative infinity, f of x approaches the same number, negative 3. Now, I'm going to go ahead and just finish it by graphing at least 2 points. Oh, what's this? Woo points? Got a typo, guys. At least 2 points on each curve. And I think I do have 2 points already right here for the left side. I'm just going to connect them. And I'm going to approach my... I have a prettier color pen. I'm going to approach my vertical asymptotes from the left. I'm just going to get really, really close to my vertical asymptotes. Just can't cross it. And then to the left end, I know the end behavior is approaching that number -3. So I'm just going to approach that line, but I won't be able to cross it. Now, a lot of people stop there, but we need another piece. Now, that's to the left side of the vertical asymptote. I need another one to the right side of it. So what we're going to do is we're just going to plug in some random x values that are to the right side of this bar, this line. So maybe let me plug in 4 and maybe 6, okay? So if I plug in 4 into this function, let's see what the y value is. F of 4 equals 4 minus 3 times 4 over 4 minus 2. I'm just trying to find the y value for this and getting a little tired, so I'm just going to type this in. So 4 minus 3 times 4 over 4 minus 2 is -4. Oh, what a beautiful point. Okay, so I know I have a point at 4, -4. Let me plot that right here, okay? 4 to the right, down 4. Here's my first point. But they wanted 2 points on each curve. So I have one right here, but you know what? I know to the right side of it, this is just going to approach this line. So I'm not really interested in, I know what the right side of this point is going to do. It's just going to get really close to -3. I want to show, because I'm expecting another point to be down there. I think it's going to go down that way. Let me actually plug in +3 into this function this time, okay? So what is f of 3? That's going to be 4 minus 3 times 3 over 3 minus 2. Here's me again typing 4 minus 3 times 3 over 3 minus 2 equals -5. So I got a very nice point again, yay. So the second point that I will plot is 3, -5. So 3 to the right, down 5. Here we go. That's a very nice point. Okay, and I know I just needed 2 points. I'm just going to go ahead and draw a tail down that's getting really, really close to my vertical asymptote. It's just not going to get there. So that's how we will graph a linear over linear graph rational function for our class. But if you have a graphing calculator, TI-84 or any other, you can use your graphing calculator's table tool to plot all these points instead of actually plugging in random x values. But that's what I want you to try for the last classwork for this week, okay? So if you take a look at number 3, or I'm sorry, page 9. Oh, got some stuff over here. Page 9 is graphing rational functions classwork problem. But notice, because a lot of times people tell me that the horizontal asymptote is at y equals 4 because they think 4 is a leading coefficient. But look, leading coefficient of the numerator is actually -1. So just be careful there. I want you to try this. This is very similar to example 3 that we just did together. Hopefully you took the notes when I was going over this in this video. Or maybe, are you watching though? Are you even watching my video? Oh, I'm sure you are. So try the graphing rational functions classwork problem for me. And maybe, guys, next week we may try to have a synchronous class meeting. Who knows? Maybe we can try to be in Zoom all at the same time and have a class. But we'll see. We'll see how this week goes. So that's the last classwork. But you do have to do Alex homework, right? The homework for this weekend will be it's always on Alex. I think I made it just called 2.5 homework. And it does have a couple of these 2.4 topics in there about the rational zeros theorem. So those are due this weekend. And if you have any questions, if you would like to come to on virtual office hour, just email me. We're going to set up a Zoom video conference so that you and I can talk about anything you need. But I will just keep on checking my email to see if anybody reach out to me, okay? Alrighty. Have a great week. Bye-bye.